In Chapter 6, we're going to be looking at chemical bonds and the compounds that they make. So we're going to start just a little bit kind of reviewing what we've been doing so far, just to think through why elements would combine and form compounds. So, a refresher. Remember that when elements combine, that the compounds are going to have different properties from the elements that make them up. The atoms of different elements are going to be held together by chemical bonds. They're sort of the glue that holds the whole thing together. And the type of bond that they have is going to determine some of the properties of that compound. So, what kind of properties are we talking about? Well, first of all, it depends on what kind of atoms are in the compound, of course. So, is this something made up of hydrogen and oxygen? Is it made up of carbon and hydrogen? Does this include gold, right? What is in it is largely going to determine what the compound is like. But additionally, it's going to be determined by how the atoms are arranged in the compound. So, how are these atoms attached to each other? What kind of bond do they have that holds them together? And are they attracted just to the other atoms, or are they attracted to other things around it? So there are so many things about the arrangement that determine the properties they would have as well. So for example, carbon and hydrogen can combine in, I don't know, hundreds, possibly thousands of different ways and have very, very different properties. So just the two elements, carbon and hydrogen, can give us things like natural gas, methane. They can give us the gasoline that we use to run our car, as well as the diesel fuel that we run our trucks with. It is the combination of things that gives us jet fuel and candle wax. It's what can be used to make the asphalt on our roads. It can be burned in our lighters as butane, and it's used as motor oil in our cars, and it even turns into plastics like making our rain boots. So all of these different things with very, very different properties all come from the same two elements. So it's really kind of interesting that combining those different elements, those two elements, can give us such different things. So don't forget, the new compound is going to be different than the elements that make them up, right? So we know hydrogen and oxygen gas, right? They're gases at room temperature. They happen to both be colorless gases, but when they make water at room temperature, that's a liquid. Salt, sodium chloride, sodium is a metal. You learned about it as an alkali metal, in fact, that's very reactive with water. It spits and sputters in water and sometimes even causes the hydrogen gas that it produces to catch on fire. And chlorine is that greenish yellow gas that's a poison and can kill people. But when we combine it, we sprinkle it on our popcorn, right? So why is it that they're so different? Well, this arrangement of atoms to form molecules or to form ionic crystalline structures is what determines what its properties are now like. Let's also refresh kind of our memory of what a chemical formula tells us and how to read a chemical formula. So remember that a chemical formula uses the symbols of the elements to represent the atoms, and it also tells us the ratio of those atoms or elements in the compound that we're talking about. So when we look at a formula like H2O, we know then that there is a 2-to-1 ratio for hydrogen to oxygen. We should be able to look at a chemical formula and be able to count atoms. So remember that the subscripts, those little numbers that follow after a letter, only apply directly to the letter in front of them. So if we look here at the formula for methane, CH4, Carbon has no subscript, so that means there's one atom of carbon. And the 4 follows the hydrogen, so that means there are 4 atoms of hydrogen. C6H14 then would mean 6 atoms of carbon and 14 atoms of hydrogen. So that's fairly straightforward, right? The subscript only applies to the letter directly in front of it. But sometimes we will see parentheses and then a little number, a subscript, outside of the parentheses. That's very much like a number outside of the parentheses in math, right? When a number appears outside of a parentheses in math, we multiply everything that's inside of the parentheses. Well, we do that here as well. But the number outside of the parentheses only multiplies what is inside of the parentheses. So if we look at the formula Ca parentheses OH parentheses 2, we have 1 calcium because it has no subscript. The O and the H, because they're both capital letters, are 2 different elements, oxygen and hydrogen. And the number outside of the parentheses multiplies them. So since without the parentheses, I would have only 1 oxygen, with the parentheses 2, I now have 2 oxygens. The same, of course, for the hydrogen. If there were a subscript inside of the parentheses besides a 1, it would multiply that as well. So we're going to spend most of our time this chapter looking at chemical bonds. So what I want you to start with is just a very basic understanding. The idea that a chemical bond acts like the glue that is holding the atoms together. And there are different kinds of chemical bonds. There are covalent bonds, and if they are covalent, they could be polar or nonpolar. There are ionic bonds, and there are hydrogen bonds, and there are even bonds called metallic bonds. Now we're going to focus our attention on the difference between covalent bonds and ionic bonds. But regardless of the type of bond that we're talking about, the type of compound that we're talking about, all chemical bonds are related to what the electrons are doing, and it's focused entirely on the valence electrons. Remember from the last chapter, our valence electrons are those that are in that highest energy level, that outermost ring. So when these valence electrons, these outermost electrons, interact with each other between atoms, that's when chemical bonds actually form. Now, how are they going to do that? Well, in atoms, there can be a transfer of electrons. We dealt a lot with ions already. Remember that ions form when atoms gain or lose electrons. Now, we haven't talked about there being any interaction to cause this change. But an atom cannot lose its electron unless there is another atom there that takes it from. So we need always to have an atom that wants to lose its electrons and another atom that wants to gain those electrons. So we will always have an atom gaining electrons. Remember, that is an anion. It has a negative charge, while we have an atom that is losing electrons and becoming a cation, or an ion with a positive charge. When the bond forms, because there is a transfer of electrons and now 2 oppositely charged ions that are attracted to each other, we have formed a bond called an ionic bond. Remember that an element's location on the periodic table can help us to figure out what type of ion it's going to form. We looked at the alkali metals group 1 as losing an electron, so they were forming positive 1 ions. Group 2, the alkaline earth metals, remember they lose their 2 electrons to form positive 2 ions. Then on the other side of the table, we had the halogens, group 17, that wanted to gain an electron in order to complete its valence shell, and they were forming negative 1 ions. And group 16, that's oxygen's group, with their 6 valence electrons needed only to gain 2, and that meant they would end up with a -2 charge. Atoms can also share their electrons. Now, why would there sometimes be a transfer of electrons and sometimes there not? Well, it comes down to whether you have one that's giving and one that's taking, or if you have two takers. If you have two elements with nearly complete valence shells, neither one of them wants to give an electron away. So if we have two halogens, both of which want an electron, neither one is willing to be the giver of the electron. So they instead share their electrons. So the electrons in the valence shell will be shared between the two atoms and will actually spend time kind of just floating out in the middle, and it will be as if both of them now have that electron and have a complete valence shell. That type of bond, when electrons are being shared, is called a covalent bond. And we'll spend more time on both ionic and covalent bonds in a future video.